Hello everybody, my name is Peter Friedrichs. I'm working for Infineon Technologies, and today in Bodo's panel about wide bandgap components in a game changer role, I would like to make you familiar with one particular topic where silicon carbide MOSFETs are used in auxiliary power supplies. For this particular purpose, we have recently launched a 1700 volt discrete MOSFET. So where we can use this component in auxiliary power supplies in a huge number of applications in the industrial environment. So what is behind this application? Usually in all of those use cases, we have inverters, and those inverters which contain power devices need to be supplied also with some auxiliary power for controller, gate drive, etc. And this auxiliary power supply is usually connected directly to the DC link. The topology which is preferred here in those applications is a very simple flyback topology as shown here on the left-hand side, but it needs a very high voltage rated fast switching device. So the reality with today's silicon devices is low efficiency and some challenges with VDSD rating. Alternatively, complex workaround solutions using parallel connections or series connections of low voltage devices are also visible in the market. However, you can see already from the circuit diagrams, they have a very high complexity. Therefore, with a 1700 volt silicon carbide MOSFET, we can come back to the simplicity of the flyback converter, but combined now with a very high efficiency, since we have also a very good derating margin for VDS. So you can see here how this solution also is advantages regarding cooling. So with the new silicon carbide based solution, we can solder the device directly to the PCB. We can cool it via thermal wires with natural convection cooling, while the silicon-based solutions need large heat sinks, a large number of components, and usually also through-hole packages. However, it needs a bit more than putting a silicon carbide MOSFET into an SMD package. So the new D2 Pack 7 leg from Infineon is a special design for each voltage class, and especially for the 1700 volt solution, we have implemented a large creepage and clearance distance of 7.1 millimeter. In addition, we have a dedicated technology to enable reflow soldering without delamination, and we use a new die attach which compensates for the higher RTH, which is usually seen in SMD packages if they are compared to through-hole. And finally, and this is very important, the chip technology comes with a new gate control condition. So what is this about? Usually those flyback solutions are directly controlled out of the flyback controller, and the output voltage of the controller, as you can see on the left-hand side, is a table of typical flyback controllers, is in the range between 12 and 13 volts. And for that reason, our new silicon carbide 1700 volt CoolSiC MOSFET is also capable to be operated already at 12 volt for on state. So therefore, we can operate this part directly out of the flyback controller. We do not need an additional driver circuit. So this is also all already seen in reality. You can see here some demo boards where we implemented this technology into a real solution. So there are two possible modes, and the quasi-resonant controller on the left-hand side or a fixed frequency controller. So both demo boards are available. So to summarize, we can offer now ultra-low loss switching with CoolSiC MOSFETs for 1700 volt, natural convection cooled with SMD components soldered directly in the PCB and operated directly from the flyback controller. Thank you very much for your kind attention.